Okay, well, what happens if you can't get the bases the same? So let's say you have 5 to the x equals 7. Well, what are you going to do there? You're not going to get the 7 to be a 5. You're not going to get the 5 to be a 7. So what we have to do is use logarithms, okay? So here are the steps. First, isolate the exponential part, this part. So the b to the x, get that by itself, okay? So there could be like other stuff around, maybe you're multiplying by something or adding something, but so get that part by itself. Then here's the idea. You know how we were doing things to both sides, like back when we were solving equations, we would add to both sides, subtract to both sides, and then we got to the point where we were squaring both sides or taking the square root of both sides. Well, now we're going to do the same thing with a logarithmic function. So you're going to take the log, either the common log or the natural log of both sides. Okay, so you're really only going to use the common log if you have a base 10. Anything else, just use the natural log, okay? Then you're going to simplify, and then you're going to solve. Okay, so on this example here, we already have the 5 to the x by itself. So you take the log of both sides. It's not a base 10, that's a 5. So I'm going to take the natural log of 5 to the x equals the natural log of 7. That's how it looks. You're just like slapping on the natural log right in front of whatever you have. Okay, so you're taking the natural log of both sides. Okay, now here you can use your property to bring that exponent down, the power property. So x times the natural log of 5 equals the natural log of 7. Now let me explain a little bit about natural logs because sometimes students get confused. This natural log of 7, that is just a number. You can put in your calculator natural log 7 and it's going to spit out a decimal number. It is just a real number. That's all it is. That's what it is, okay? So we're trying to solve for the variable x, the natural log of 5. That is just a number. Again, you can put it in your calculator and get some decimal approximation. In fact, you know what? I'm going to show you that because maybe that'll make more sense this next part. So what is the natural log of 5? It's about 1.61. So x times 1.61. Now, we wouldn't really do this, but I want you to understand that these are just numbers. What's the natural log of 7? Natural log of 7. Natural log of 7 is 1.95. Now, we don't do it this way. Don't do this. Because at some point you might have to, but this is not an exact answer. This is now an approximation. And a lot of times they want exact answers. Sometimes they want both, but we'll talk about that. Okay, so see what you have here? That just means you could divide both sides by 1.61. Okay? And you'd solve for x. Okay. But what we're going to do is we have x natural log 5 to get the exact answer and not a decimal approximation. We're going to divide both sides by the natural log of 5. So the exact answer is x equals natural log 7 divided by natural log 5. If they want a decimal approximation, then we put that in the calculator. Okay, we'll show you how to do that too. But I don't think they want that on this example. They just want exact answers. Okay, so here we go. You've got 4 to the x equals 15. So you're going to take the natural log of both sides. Why aren't we using a common log? Because we don't have a base 10. It's a base 4. Okay, bring down the x. X times the natural log of 4 equals the natural log of 15. Divide both sides by the natural log of 4 because it's just a number. You're just dividing both sides by a number. And you get x equals the natural log of 15 divided by the natural log of 4. And that's the exact answer. I could put it in my calculator and get a decimal approximation, but I'm not going to. Okay, so here's another example. Oh, this one has a base 10. You see it? Okay, so we're going to take the common log of both sides because that'll actually be helpful to us. Because when I have a common log and I have base 10, that's that property 3, right? It's just x. Okay, so you could think of a little 10 here that we don't write, but that's just the exponent then, because the base here is matching the base in the argument. Okay, so you have x equals log 120,000. Okay, and if you want a decimal approximation, you can put that in the calculator as well. Okay, so I'm going to go through the decimal approximations for you because, sometimes they want that. So remember on your calculator, you need to put this in parentheses. You have to close that off. Otherwise, you're going to get the wrong decimal approximation. So I'm going to go natural log. I have a parenthesis. I put in the 15. I close that parenthesis. You've got to put that in there. Then you hit the division bar. And then natural log 4. I'll close that off too. And it equals about 1.95. Okay, so sometimes they want a decimal approximation. They didn't ask for that, but it's okay. All right, on the other one, well, how would you do a common log? You have a common log button on your calculator. So you just hit LOG, that button, and then put in the 1200000. Did I get enough zeros? Yep. All right, close off the parenthesis, and I get, it's about 5.08. Practice that on your calculator so that if they ask for a decimal approximation, you'll know how to do it. Okay.